Hey everyone, and welcome! Today, we're going to go on a bit of a quest, a programming adventure really. We're going to tackle one of the most famous and sometimes, let's be honest, infamous design patterns in Java, the singleton. Our goal? To find that one true instance.
So, let me ask you something. Have you ever been, deep in a project and you have that moment where you realize you need one and only one object to handle something super critical? Maybe it's a logger or a central config file. If you've been there, you know exactly the problem we're talking about today.
And that's where the singleton pattern comes in. It's what's known as a creational pattern, and honestly, it has two simple but really powerful goals. First, it makes sure a class has only one instance, period. Second, it gives you a single global way to get to that one instance. Not sounds simple, right? But as we're about to find out, getting to a truly perfect singleton, well, that path has a few hidden traps. Okay, so here's our game plan for this whole quest. We'll kick things off with the basics. Then we'll look at the first, simplest ways people try to build a singleton. And then, we're going to face our first big challenge, multi-threading. From there, we'll level up our solution to make it truly thread-safe, take on some final bosses, and at the very end, I'll hook you up with a cheat sheet so you can pick the right pattern for your own adventures. All right, let's do this. Our quest officially begins now. Before we start actually writing code and forging our singleton, let's take a look around and really get why this pattern is such a vital tool in any developer's toolkit. I mean, just think about it for a second. You only want one logging system writing to a file, right? Otherwise, you just have chaos. You need one configuration manager to make sure everyone's playing by the same rules, and you definitely want just one object managing your pool of database connections to be efficient. In all these situations, having more than one instance would just cause conflicts, waste resources, or give you totally inconsistent results. The singleton is what keeps the peace. Okay, time to get our hands dirty and start building. Our first couple of attempts at creating a singleton, they seem super simple and honestly pretty effective at first glance. But as you're about to see, they're hiding a really critical weakness that we're going to uncover pretty quick.
You can kind of think of it like this. Eager initialization is like a factory that flips on its main machine the second the power comes on for the day. It's always ready to go, for sure, but it's using up energy right from the start. Lazy initialization, on the other hand, is a bit of a smarter factory. It keeps that big machine turned off until the very first order comes in. It saves resources, which is great, but that whole startup process, yeah, that's where our troubles are about to begin.
So here's that eager approach. The instance gets created right away. It's dead simple, it's reliable, and it's already thread-safe just because of how Java loads classes. The only real downside? It's just sitting there, taking up memory, even if our app never actually uses it. Kind of wasteful, don't you think? Okay, now this looks way more efficient. We just check if the instance is null, and if it is, we create it. Boom. No wasted resources if it's never needed. This is lazy loading, and man, it really seems like the perfect solution. But this is where our little quest takes a bit of a dark turn, because there's a hidden monster lurking in this code. And yep, that monster's name is multi-threading. What we thought was this perfect, efficient solution is about to fail, and fails spectacularly the second more than one thread gets involved. This right here is the main event of our singleton story.
So let's paint a picture here. Imagine you've got two threads running in your application, and they both need the singleton. They both call that getInstance method at almost the exact same time. What do you think is going to happen?
Okay, let's watch this disaster unfold in slow-mo. Thread A comes along, it checks, and it sees the instance is null. But before it can actually create the object, the system scheduler just yanks it out and puts thread B in. So thread B comes in, it also checks, and what does it see? It also sees that the instance is null. The trap is now officially set. Thread A eventually wakes up and creates an object, and then, a millisecond later, thread B wakes up and it creates another object. Our singleton's one and only rule has been completely shattered. And yeah, singleton. Broken. We now have two instances running around, which is the one thing, the only thing, this pattern is supposed to prevent. Our slick, lazy approach has totally failed us. But hey, don't worry, our hero can evolve. We are going to level up our implementation and learn how to beat this multi-threading monster once and for all.
So, our first two attempts at a fix are kind of like the classic tortoise and the hare story. The synchronize method, that's our tortoise. It's simple, it's safe. It basically puts a big lock on the entire method, making sure only one thread can get in at a time.
but man is it slow. Every single thread has to wait in line even long after the instance has been created. Then you've got double-checked locking. That's the hair. It's way faster, way more clever. It only uses that expensive lock in the one brief moment when the instance is actually being created. All the other threads can just race right on through.
But what if I told you there's an even more elegant solution? I'm talking about one that's lazy, perfectly thread safe, and get this, doesn't need any of those expensive synchronized keywords at all. This, my friends, is the Bill Pugh Singleton implementation, and it is a total game changer.
And this is where the real magic happens. See, the instance is held inside a private static inner class. Now, the key here is that the Java virtual machine itself guarantees that when a class gets initialized, that whole process is thread safe. The inner class isn't even loaded until someone calls getInstance, and when they do, the JVM itself makes sure that only one thread can create the instance. It's lazy, it's fast, and its safety is literally baked right into the language itself. How cool is that?
So, we've beaten the multi-threading monster. We have a fast, safe, lazy-loaded Singleton. We should be celebrating, right? Well, not so fast. Turns out there are two final bosses, two pretty advanced techniques that can break even our brilliant Bill Pugh implementation. So our final bad guys are reflection and serialization. Using something called the Reflection API, a really determined programmer can actually bypass our private constructor and just create new instances whenever they want. And if you serialize your Singleton, save it to a file, and then deserialize it later, Java will, by default, just create a brand new object, again, breaking the pattern completely.
So how do we build an unbreakable shield against these super advanced attacks? We need an ultimate weapon. And it actually comes from a legendary source, the Java architect Joshua Bloch himself. He proposed what's now considered the most robust method of all, making the Singleton an enum.
This is it, the enum Singleton. The Java language itself promises you that an enum instance is only created once. It's automatically thread-safe, it's completely immune to attacks from reflection, and it handles serialization perfectly right out of the box. It is, for all practical purposes, unbreakable. And with that, we have completed our quest. We've faced down every challenge and found the ultimate solution. So now it's time to collect the loot, the spoils of our victory. Your very own Singleton cheat sheet. Okay, this table really sums it all up nicely. If you need something dead simple and you know for a fact you're always going to use it, Eager is totally fine. For most real-world multi-threaded apps, the Bill Pugh implementation is going to be your go-to. It's that perfect balance of performance and safety. And when you need an absolutely bulletproof, unbreakable guarantee of a single instance, especially when you're worried about things like serialization, the enum Singleton is your champion, no question.
So there you have it. You've seen the whole journey, from a simple idea to a totally unbreakable pattern. You get the trade-offs now, right? Between simplicity, performance, and rock-solid safety. So the next time you're coding and you need to make sure there's one and only one instance, the choice is yours. Which Singleton are you going to build?